some demos for IP tables built in Linux. And in this demo, I will use this network topology. We have two subnets, network A and network B. They are connected by a router. So we have 5 loads in this network. And so here for this network A, the IP address for this network is 192.168.1.0/24, and the network B is here we have 1 replaced by 2, and each of this network has 2 loads, and they are connected by load 3, which acts as a router between them. And the router has 2 interfaces. One interface connects to network A, the other interface connects to network B. And to have this demo, I use the instructions given by Steve Gordon. He's a researcher in communication and cybersecurity. So I give all credits to him. It takes a lot of time to set up this virtual network. In fact, he sets up several virtual networks automatically, making my life much easier. For some of you, if you want to try out by yourself, then you can search for this webpage, like automatic creation of virtual networks with a virtual VBox manage. In fact, if you just search word virtual network Steve Gordon, I'm sure whether, let's see whether it's this one. No, not this one. You can have another keyword, automatic. Yeah, to make it easier, then you remember this title, Automatic Creation of Virtual Network by Stephen Gordon. Then you can follow his instruction. Then you can easily create this topology in VirtualBox. So here is this is the network, and this topology is generated within VirtualBox. My VirtualBox. Here you see I have several loads. I have load 1, load 2, load 3, load 4, load 5. These are the components of this network. And before we introduce the demo, I'd like to quickly go through IP table with you. So the IP tables in Linux, it has 3 interactive interfaces. In fact, this is the architecture of IP table. So IP table, within Linux kernel, there's a net filter component. So in fact, IP tables interact with this network filter, which interacts with the network interface cards. That's how IP table communicate with the network interface card in Linux. In IP tables, there are several tables, and for our purpose, we will only use a filter table. In fact, it can be using the NAT network address translation, and also magnet to altering packets. It will be available by using the table, this option. If we do not specify this option -t, then it will be by default the filter table. And the tables contain chains. So here you see this figure. This is the local process. That's the IP table. In the Linux. In fact, it has this. When it has incoming packet, it have this routing decision whether it's an input to the device or whether the device only forwards this packet. And then have this output. If it goes into the device, then there's some control by IP table. Then it outputs the the decision on the IP packet, and then forward to this post routing chain. Then it becomes outgoing packets from this device. So it has these 4 chains. We will only focus on input chain, output chain, and forward chain later on. For this chain, it uses rules, and the rules consist of matching conditions based on the protocol, the source and destination IP address, and interface. And it can be quite complicated, so we will only focus on the basic conditions. And the target within IP table includes accept, drop, return, reject, and other rules. And we will focus on accept and drop. Basically, when a packet arrives at the device, the IP table will inspect the packet header, and it will be checked against the rules in the chain from the very beginning to the last one. If the rule does not match, then it will take action as specified by the default. So this is the usage of the IP table's syntax. You see IP table, and then you need to provide the table. By default, it's a filter. Then it's an operation chain, whether it's input chain or output chain or forward chain. Then we need to specify the protocol name, and then the source IP address by S, and -d, that's destination IP address. And sometimes you may also want to provide some extra information by initial interface and this incoming interface. This is outgoing interface, and then it has parameters. And the last one, this -j target. That's target is for whether it is used to drop the packet or it's an accepted packet. So we have this. If you want to see more about the IP tables, then you can use main IP tables or IP table 2- with help. So here there are some examples. Let's just take a look at the first example. So the aim is to drop all ICMP packets sent by this computer. That's exactly what we have done in the lecture. So we assume the default policy is accept. Then we assume the filter table is empty. And we append a new rule. And with -A. And since it's sent by this computer, so the chain should be output chain. The protocol is ICMP. The target is drop. Then with this design, then we have this implementation. Iptables dash capital A to append this output chain with the protocol ICMP, and the target, the action to be taken is drop. That's it. So now let's move on to our demo in terminal. So I use my terminal to SSH these terminals, these loads in the previous topology: load 1, load 2, load 3, load 4, load 5. Load 3 is here. So to give you certain information, then I can use ifconfig, and is 1. Then you get this IP address that is 192.168.1.11. And if we go to this one, we have Ethernet 1. This one is node 2's IP address. So the address information is .12 for the computer. And that's load 4. That's ifconfig Ethernet 1. So in this case, the network address is 192.168.2.0/24, and the computer's node 4 address is .21. And we have ifconfig Ethernet 1. Then the address for this node is 22 in this network, in the subnet 2. That's network B. And let's move on to this router. That's node 3. So if I use, here in fact you already have this. Here on this router, it has 3 interfaces. Ethernet 0 is used to connect to the VirtualBox, to connect to the external network. And then within this our topology, we have Ethernet 1 and Ethernet 2. So Ethernet 1, this interface has IP address .1 in network A, and Ethernet 2, this interface has IP address .1 for subnet 2. And that's all. That's for the introduction of these loads. Then let's look at the examples we want to demo. So first, let's look at all these examples will be treated separately. It means I will flash the IP table rules before I continue the next example. So let's look at example 1. So I set the firewall at load 1, and rule 1 is block ping to load 1. So this is to block all the incoming ping request to load 1. Rule 2 is block ping to load 5 from load 1. So 1 is input chain, the other one, that's rule 2 is output chain. So let's take a look at this. First, I need the pseudo user to run IP tables, to manipulate IP tables. So to make it easier, I write su, and I give the password. Now you see I'm running load 1 as root user. Then I use IP tables. I first want to see what are the existing rules. So then I use a -L to list all the existing rules. And in the lecture we have this one, so I want to remove this rule. So I use iptables dot f, that's a flash, to flash the existing rule. And let's double check. So now you see the table is relatively clean here, and the default policy is accept. So what I need to do is now we can first check whether we can ping to network this node 1. So I just ping clear, then I use load 4 to ping this load, and then I can give a little bit more information. I want to only send 5 ICMP requests to load 1. So this -C indicates the count, and then I specify we have 92.168.1.11. So here it mentions 5 packets transmitted, 5 received, so 0 loss, so that's good. Now let's change this table. Like we add this rule, iptables and -A to append a policy rule, and we have it's for input, that's input chain. Then we add protocol, that's ICMP, and we add the target, that's action, is drop. We can see the list. Here you have this the input chain. So the target is drop, and the protocol is ICMP. The source is anywhere. The destination, here I should specify the port number. That's I should specify the IP address, excuse me, to make it more accurate. We have destination IP address, that's 92.168.1.11. Then it's the destination is this node. Okay, so first let's try whether in the same network node 2 can ping node 1. So I use ping C3, and then this address. You see here, nothing happens, and then we change to another one. Okay, it mentions 3 packets transmitted, 0 received, so it's all the packets are lost. And we try again the load 3, or maybe load 5. To save time, I will copy this. So you see, it's a stuck, and then it gives out this error message, 100% packet loss. So it means this file policy takes effect. Then we flash the table. Now let's look at rule 2. Rule 2 is to block ping to load 5 from load 1. And I just change a little bit from here. So now it's the source IP address is load 1 and destination IP address is 192.168.2.load 5, that's 22 here. And then we use the same load 3 like here. And we have 3 rules to try out. In this case, because it is router, its major function is to forward traffic between the network A and the network B. So we will add policy rules to the forward chain instead of the input or output chain. First, we change back to network to load 3, and first I will show you the interface. So it has interface. This is Ethernet 1. This is IP address Ethernet 2, and you see it's the IP address within the network B. And you see I already run with root user, so I don't need to write sudo. And IP tables, first I want to see what are the existing policies there. Nothing, so it's clear. And then we can see, we can look at the load 2 and load 4. So the rule is to block SSH from load 4 to load 2. So first let's see whether we can SSH, we can log in load 2 from load 4. And we use SSH 192.168.2.21. It takes some time, but now you see it's IP address for the, and here it's I did wrong. I should write SSH 92.68.1.12. That's the IP address of load 2. It's here. Now you see I already log in to load 2. And if you want to get confirmation, if I write Ethernet 1, it's the same as here. So it's exactly the same information. No. So now I log out again. It will be load 4 back. Now let's look at how can we add the firewall policy to block SSH request from load 4 to load 2. In this case, I need to use Iptables then to append a new policy rule, and in this case it's a forward chain, and I need to give the source IP address, that's 92.168.2.21, that's node 4, and destination is 92.68.1.12. This is destination, and the protocol is TCP. And here we need to specify the destination port number. And in Iptables, the usage is destination port. Then I specify 22, the port number for SSH. Then I add the target is drop. Okay, so now let's take a look at the Iptable policy rules. So in this forward chain, then it's drop, and the source is load 4, the destination is load 2, protocol is TCP, and the destination port number, that's for SSH. And for some of the SSH devices, they also use UDP to forward SSH. So in this case, to make sure everything works fine, then I also add UDP. Okay, now let's change to this 4 loads. Let's say whether I can log in load 2 from load 4. Should have it in history. So I have this command. No, nothing happened. It means this firewall rule takes effect. Now if we change back, if I flash this rule, now it's clean. Now let's try again. You see here, I successfully log in load 2 from node 4. So this is for rule 3 in our example. Again, it's similar for block SSH from load 5 to load 1. In this case, I only need to change slightly. Here, load 5 to load 1, and we have TCP, destination port drop. And in this case, I will only use TCP to see whether this rule works or not. Here, then SSH 192.168.1.11. Okay, it works. So it means it only controls the TCP protocol for the SSH request. I don't need to add UDP. Now let's change it back. If I flash the policy rules, and then let's see whether we can log in load 1 from load 5. I think so. Here, now it's successful. Okay, let's check rule 5 to block SSH from network B to network A. In this case, so I need to change this source IP address as the network. So the network IP address is 0/24, destination (0/4). And okay, let's take a look at whether it works. So I use load 5 to log into load 1. It didn't work. I use load 5 to log into load 2. It's not working. And I use load I first need to log out. I see the problem here because previously I didn't log out from load 4, and now the connection between load 4 and load 2 is already broken, so I cannot do anything with load 4 here. That's the reason. You see? So if I flash the table and if I change back to load 4, now it's active. I'm back to load 4. And one more example. Even I have this one. Oops. So even I have this policy rule, but you see this rule is for network B to SSH network A. It doesn't control anything for the internal SSH within these two networks. It means if I want to log in to load 5 from load 4, it should work. Yes, it works. But if I want to log to load 2, then it's not working. Again, for load 1 to log into load 2, it works. And here I want to try to log in from load 2 to load 5. Let's see whether it works. You see, it works. So it means this rule only control the traffic the SSH request from network B to network A. If network A wants to SSH network B, then it's fine. Okay, that's for example 2. In the end, let's look at example 3. The firewall is again placed at network node 3. And node 5, in fact, maintains a web page, very simple web page. Let me show you. So I set up the web page beforehand. By default, this topology network created by Steve Gordon does not maintain any web server, but I activate it. Now, if if you want to visit local web page and the web server maintained locally, then it has this local host. The IP address is 127.0.0.1. That's the web server IP address locally. So I can use wget, that's web page get. I can use this IP address to see. Now you can see it gets this index. I already get it previously, so it gives this extra .1 to differentiate from the previous one. And you can also, if you specify localhost, then it's the same. You get the web page. So basically, the web server at node 5 is active in this case. It means if we want to visit the web page maintained at node 5, then let's try wget. Then I have, when use wget, it's a HTTP request, so we don't need to specify the port number. Then I use 92.168.2.22. Okay, this web page is already downloaded. You may wonder what is inside. Let's take a look at it. So I can use vim index. Oh, that's the very simple web page. This is a default web page for this server. Very simple HTML file. You know it works. And now let's look at node 3, this router. And first, let's check the existing rules. It's there, so I will flash it. And then I will add this rule from this this example, rule 6, block web request from node 1 to node 5. Okay, then it's very similar. So we have this forward, that's the forward chain, and we appended this policy to the IP table database. And here the source IP address is 1.11 and destination IP address is 2.22. That's node 5's IP address. And we have the protocol TCP. The destination port number is 80. and we don't need to specify the source port number. And then we can see the rule to drop from this node 1 to node 5. Let's see whether it takes effect. I want to wget 92 dot. It should be in the history. Yeah, this one. You see it's connecting to this one. It's connecting. It didn't give you any full information. So it means this request was dropped by router 3. If we change to load 2, let's see. wget 92.68.2.22. Now it works, and we can check what is the file. Yeah, this is a file of the home web page. It means the router only drop the HTTP request from node 1 to node 5. So now let's check the last rule, block web request from network A to node 5. That's interesting. So we first flash it, and then we add the rule. And in this case, the source IP address should be the network. So then it's 0/24, and the others are the same. Now we have this new policy, and by default it's accept. Then we add this drop. So it's already mentioned, okay, the connection timed out, it tries again. So I don't want you to try. Oops. I want the load to try after I update the policy. No, it didn't work. What about node 2? No, it's not working. What about node 4? wget 92.168.2.22. Okay, it works. So it means this new policy rule added to the IP tables at load 3 works as we expect. So that's all for the demos of IP tables. Hope you will like it.